Alright, so I've rebooted my machine, I've taken off my camera, and my hope is that we won't have too much internet lag, but the videos seem to be lagging for people last class. So hopefully the bandwidth is pretty good right now, and I guess the internet had some issues yesterday. So maybe that's still going on. Alright, so send me an attendance ping, let me know you're here. And my goal today is to talk about when writing a C program, how do you get arguments from the command line? And then once you have those arguments, if you want to treat those arguments as numbers so that you can, manipulate them, how do we do that? And those are the two things we're going to need to do ODP 408. So we're going to spend pretty much the whole class going through those two topics. So any questions before we start? Alright, so let's talk about argc, argv. So when you write a main program in C, it could be main, could be int main, could be void main. I'll just play with void main. So void main. And you can do just paren, and that works perfectly fine. And that's your setup if you're just going to run a program. So you're going to write a program called, SQR, which prints out the square of a number, right? So you have an sqr.c, and you compile it, and we'll make an executable called, SQR, for example. And if we're just making, a program that we don't have to give any information to, we can just say main paren. So let's write some code while we go through this. Alright, so this is like a hello world. Yeah, so like I say, I was lagging last period too. And the whole net was struggling yesterday. Yeah, so the video should be intact. So worst case, we can take it as an online lecture. But I can't turn off anything further here. I've got a minimal complement of stuff running. Alright, we'll see what we can do. So here's sqr.c, and we can compile that, and when we run it, it says hello. And if I put other stuff after here, right, it doesn't change anything about my program. But suppose you want to write a program where you can actually take these command line arguments that are being specified after the program name and do something with them. So this is where argc and argv come in. And the basic setup is you specify two arguments to this function. The first is an integer, and the second is a char star star. Alright, so main is a function. Everything that you write in a C program is a function. Main's a function. It happens to have a special name, main, which causes it to be, executed by bash. So if you want to pass things to main, you put two arguments in this function. The first one is an integer, the second one is a char star star. And we'll talk about why it's a char star star another day. But the traditional names for these arguments are argc and argv. Alright, so argument is just a term for, something you pass to a function. So we would say this has two arguments. The first is called this, the second is called that. So they're called arg something because they're arguments. It's just terminology. The C is short for count, and the V is short for vector. And these do two things. The first thing, this integer tells you how many arguments you had when you ran your program. And the second argument, argv, that's an array that contains each of your arguments. So let's say we're writing this program sqr. And I compile it, right? sqr.c changes into sqr. And let's say I just run sqr. argc will be equal to 1. And that's telling me, hey, on this line where I ran my program, I had one word, right? My word was just sqr. Yeah, I can't switch to Discord at this point. And I don't know how the bandwidth is on that for sharing video and such. I don't think there's a whole lot I can tweak in Zoom. Hold on, let me stop my share. Let me see if I can like find an option. Hold on one sec. Da, da, da. So I have my video turned off. So that should be good. My audio is minimal. Yeah, I don't see a lot of possibilities there. And yeah, it's probably not Zoom, although I know Zoom is a resource consumer, at least on my machine, but this seems more like internet bandwidth. Let me check one thing. Yeah, there's nothing obvious going on this side. So I think we gotta live with it and see what we can do, and if it's unwatchable, just kind of hang out. And I'm not gonna worry too much about attendance pings today because people are also getting disconnected. But just kind of hang out and then watch the video. But we'll do what we can here. So if I run my program just by saying the name of the program, I've got one thing on my command line, argc is going to be equal to 1. If I say sqr, hello, I've got two things on my command line, argc is going to be equal to 2. If I say sqr hello 25, I've got 1, 2, 3 things on my command line, argc is going to be 3. So argc is really easy to interpret. It's the number of things that were on the command line when I ran my program, where we count, things as being separated by spaces. So let's put an argc argv into our main program, and let's do the following. Right? And so remember how printf works, right? If I say printf and I have something in quotation marks, but I have some percents in there, this %d would get replaced by the value of this integer. If I had a %g, it would get replaced by the value of what should be a double precision floating point number. So this should print out argc is, and then it should show me the actual value of this first argument, argc. So if I compile this up and I run my program sqr, it says argc is 1. If I say SQR, this is a test, how many things do I have on my command line? I've got 1, 2, 3, 4, 5. Tells me argc is 5. And it's counting by things that are separated by spaces. So, you know, if I do this, argc is 6. 1, 2, 3, 4. All of this is argument 5, and then argument 6. So by looking at argc, I can tell how many things I've got here. All right, argv is the thing that tells us what those actual arguments are. So if argc is 3, argv is an array. Argv bracket 0 would be SQR, argv bracket 1 would be hello, argv bracket 2 would be 25. So let's go ahead and look at argv now. And you know, most languages count starting from 0 instead of 1, so the edge cases can be a little tricky. If argc is 3, I've got 1, 2, 3 arguments. The names of those in my array are bracket 0, bracket 1, bracket 2. So if argc is 3, I can go up to and including bracket 2. If argc was 10, I could go up to and including bracket 9. But if I try to go to bracket 3, that doesn't exist. So the way I want to code this loop is, you know, I'm going to go from 0 up to 1 less than argc. So I less than argc. And I'm going to say argument number %d is, and I'll do a %s. And I'll print out I, and I'll print out argv bracket I. Yeah, we're not going to worry about car star star too much yet. For now, just take it as we always say car star star before this argument. But we'll break that down in a few days. But it's basically a pointer to a pointer. So, or a pointer to a car star, which is a string. And a pointer to a string means it's an array of strings. But if that doesn't make sense, don't get bogged down on it right now, because we can do what we need to do for 408 and 409 without understanding this. But we will understand this before long. Alright, so I'm going to loop through all the valid arguments in my argv array, and I'm going to print them each out, right? So I'm going to print out argument number, and I'm going to print the value of I, and I'm going to say is, and then %s will print this as a string. So I'm going to do square hello 25. And there we go. Argc is 3, argument 0 was SQR, argument 1 was hello, argument 2 was 25, 0, 1, 2. And that's really all you need to know about accessing your command line arguments. If I just say SQR, argc will be 1, and that first argument is, you know, SQR. If I have a different program like ha ha ha, and I run that, argument 0 is ha ha ha. It's whatever I put in this first piece of my command. If I do dot slash ha ha ha, argument 0 is dot slash ha ha ha. But if I put other things on the same command line, then argc counts how many things were on here, 4 in this case, and each element of this argv array is the corresponding string. All right, so other questions about that? argv is an array of every command line argument given, yes. All right, so what if I decided to what if I just decided to print the first 10 elements of argv without worrying about argc? So I'm just going to go from 0 to 10. I'm going to print out argument %d is argv bracket I from 0 through 9. This is not something you want to do, right? In general, we don't want to look at an element of argv unless we know that argc tells us that that argument exists. In other words, if we're going to do something with argv bracket 2, make sure argc is at least 3. If I don't know how many arguments were put on the command line, what is my expectation if I start trying to do something with argv bracket 2? Right? The reality is you're probably going to get a seg fault. Worst case, you're going to get a seg fault. Best case, you're going to get bizarre information. Right? So if you're writing a program and you expect there to be, 2 things after this, make sure before you do anything with those that you check argc and confirm that you actually do have 2 arguments. All right, so suppose we ignore that and we just say, hey, I'm just going to print, the first 10 elements of argv. Well, it's not too bad. So I'll say square, this is a test. And it says, argument 0 is sqr, this is a test. And then the next argument is null, and then these other arguments are like all kinds of interesting things. And these are not things I typed on my command line. What you're doing is you're haphazardly going through memory and you're accessing whatever happens to be in there. And because I'm on a Linux system and things are set up the way they are, what happens to be in memory after my arguments is what's called my environment variables. And we got URLs in here, and we got paths to directories and all kinds of stuff. Right? So always check argc before you use argv. All right, so let's talk about scanning. So let's expand this function sqr, and let's have it take a number and print the square of it, right? So multiply the number by itself. This is almost what ODP 408 is doing, but 408 is doing a square root. So I'm not going to bother printing out argc yet, but let's just make a square function. So if I'm going to say square 5, this is argv bracket 0, this is argv bracket 1. So the thing I want to square is in argv bracket 1, right? That's where the argument is. Yeah, definitely. And good encryption systems will make sure, for example, that things like, private encryption keys are not laying around in memory where you could accidentally stumble into it by doing something like what we're doing. But, on any given system, that's always a possibility. And that's one way of doing exploits is overflowing buffers, right, and either reading or writing into areas where where you weren't necessarily supposed to. All right, so I'm going to do this. Let's just start off. Let's just print out the value of that first argument and make sure that we're getting a hold of it correctly. And this is always good test code to do. If you're not sure if this should be a 1 or a 0 or a 2, try it, right? So I get a warning if I do this. Well, okay, let me. Right, this argument is a string. It's a collection of characters. So we print it with a %s. So if I do this and I say sqr5, I can see that, you know, the first argument that I'm looking at is a 5. And if I say sqr7, it tells me it's a 7. So if I wanted to print the square of this, I could try to do this. Right, I could try to do argv1 times argv1. And that's not going to work. I'm going to get all kinds of backtalk from the compiler. And it's saying invalid operands to the binary operator star. So you cannot multiply two strings together, and even though this is, you know, a string containing the single character 5, it's still not an integer. It's still just a collection of characters. To us it looks like an integer, but to the computer it's just characters. And so if we want to do something like you know, manipulate this arithmetically, we have to change it into an integer. And that's what sscanf is going to do. So we got some good chat going on here. So yeah, if someone has access to your machine, and they can write a C program, they can, you know, access anything in memory that they have access to. If they're logged in as you know, if you're logged in and you walk away, there's probably bigger problems than, you know, they could write something that reads memory. But it's possible, you know, that even logged in as someone else on a shared system, you can tap into someone else's memory when their process exits, for example. And it's definitely a thing. How do you block it from happening? Well, apparently it's not easy, because today in 2021 we still, you know, see headlines coming out about, you know, here's a new exploit that someone discovered in this or that or this other thing. Bash, which has been around for years, somebody discovered an exploit several years ago, even though it had been out for a long time before that. I don't know what happened with Facebook yesterday, but something happened. So yeah, I mean, these things are tricky to avoid, and, you know, some languages like Java is designed to try to make it harder to have, you know, buffer overflows and things like that. They avoid pointers, for example. But there's so many ways to compromise a system, and computers were not initially developed with, I think, any mindset of, you know, what if somebody tries to do something with this that we weren't expecting. And as things became, you know, shared resources, and then eventually networked, and eventually, you know, a worldwide, solar system-wide network, right? It's a definite challenge. Yeah, so I heard there was something about routing information too. And yeah, if someone has physical access to your computer, you can consider it compromised, definitely. And yeah, even if you don't have root access, like I say, you could, you know, put something in there so that when they run a command, it does something different from what they think. You know, you can put a keystroke logger, stuff like that. There's all kinds of ways to compromise security. All right, so I run square 5, argv bracket 1 has that 5 in it, but I can't just multiply it by saying times, right? I have to convert it to an integer, so this is sscanf. So There are security classes you can take, especially at a university, where you'll actually play around with some of these things. You'll actually, create a buffer overflow to try to give yourself root access on a system. There's a cool book called Ethical Hacking that's a really thick book, and it goes through a lot of low-level detail. It's actually a great way to learn C and operating system theory, and it takes you through a lot of exercises in doing these things. But yeah, take a computer security class, and you'll do all of this stuff. So how do we convert from a string to a number? Well, I'm going to make an integer variable called number, and I'm going to say sscanf. Okay, so sscanf takes a number of arguments. The first one is the string, the collection of characters that you're trying to convert. In this case, it's argv bracket 1. All right. The second argument is a %d. That's like a string in printf. That says what is the type of thing I'm trying to convert. I'm looking for an integer. So I want to look in this string argv bracket 1 for an integer. That's what the %d is saying. And then this third piece is saying if you find an integer, store it in this variable called number. And if this is an integer, we have to put an ampersand in front. And that's something we'll also dig into in the coming weeks. But for now, just remember, if you're doing an integer, put an ampersand in front. All right, so this should convert our string to an integer, and you can't embed it in a printf statement like someone just asked in chat. You've got to say take the converted result, store it in this argument, and then you can go ahead in your print statement, and we could print out as an integer number times number, and that should work. So compile should be clean, and then if I say sqr6, it prints out 36. All right, so questions about what we have so far, because we're going to build on it. So argv is the list of arguments, because we put it in the argument list for main, and argv bracket 1 will be that first argument. Sscanf will convert it to an integer. That's what the %d does, and it will save the converted value in this variable number, and then my print statement will just print number times number. So if I say sqr -12, it prints out 144. So yeah, for compiling, I say -o to put the output file in sqr. But if you do ODP 408, we're going to need to use square roots, and for square roots, you also need to do -lm when you compile. So sscanf converts from a string. We tell it what is the string that we want to convert, and then it goes ahead and does this conversion. Scanf will actually read from standard in and convert, and we're never ever going to use scanf in this course, okay, and we'll talk about why tomorrow, but we're going to avoid scanf. We're always going to use sscanf, and I guarantee you'll have fewer problems if you stick with sscanf.
So I was looking in the book, the one from last quarter when I took Intro to C.
Mm-hmm.
So it's and I was trying to find sscanf, and I was having a hard time finding it in the book. I didn't see it in the index, but I was probably just looking in the wrong spot.
I'd be surprised. This is the big C primer book, right?
Yes.
Yeah, I'd be surprised if it didn't have sscanf, but it's possible. but it's a standard part of the string library.
Is this one of those, like, if you can't find it in your book, just go to the man pages and just, read up on it in the man pages?
Yes, you can always man scanf, and it's actually bundled together with scanf, fscanf, sscanf, vscanf, vs, vfs, and so on. Scanf has more issues because it will oftentimes throw your code into an infinite loop if you don't use it quite the right way. And we'll see some examples of that.
Definitely seen that.
Yeah. But that's going to be tomorrow's topic. All right. So does this make basic sense? These two lines. These two lines are everything, right? This is the difference between, not worrying about command line arguments and processing inputs versus I've been working on this for 12 hours and I can't even get my arguments processed, right? This is not a very complex concept once you understand it, but there's so much that can go wrong with just these two statements. And we'll break these down further. We're going to expand on them in a few minutes, right? But I want to make sure people understand what's going on here. This is taking a string, saying look for an integer, and if you find it, store the value of that integer in this argument, this integer called number. And then this is just our plain old printf statement. All right, so what can go wrong with this? I can say, square 7 and it gives me 49. What if I just say SQR and I don't give it an argument? There's my dreaded seg fault. All right. When you get a seg fault, right, don't just start changing things to try to get rid of it. Understand where the seg fault comes from, right? Because there's definitely a problem in the code somewhere. And in my case, the problem is I'm doing something I said not to do about 10 minutes ago. I'm doing something with argv bracket 1 without knowing if argv bracket 1 even exists. Right? So when you're working with command line arguments, I know that argv bracket 0 always exists. That's the name of the program. But I don't know if argv bracket 1 exists. If I don't put a command line argument, if I just say SQR, this thing doesn't exist. And if I try to do something with that, for example, try to use it as an argument to sscanf, that's my seg fault. And it's pretty easy to avoid that. Let's just check argc. So if argc is not equal to, and I'm looking for two things on the command line. I'm just going to print a message, and I'm going to return. All right, so I'm going to check argc, and if it's not equal to 2, I'll print a message, hey, you need to specify an argument, and I'll return. Otherwise, if argc is 2, then I know that, there were two things given, 1, 2, and so argv bracket 1 will be, whatever that second argument was. So now I can say GCC, and if I say SQR, it'll say error. And if I say SQR3, it'll print the square of 3. All right, still with me here? So use argc to make sure that you've got the arguments that you're expecting to have. All right, so the other issue is, what if I say SQR and I try to take the square of ABC? I get some weird number. Right? So what's up with that? Why is that the square of ABC? Well, sometimes it's something different. This is a semi-random number. And, you know, if I execute a command, the result of square ABC changes. And we're back to this thing where we're like peeking around in memory and we're picking up kind of random values. All right. Could this be an if-else? Yes, absolutely. I could have said else do this. The reason I didn't, though, is because I love indenting, but I don't want to indent more than I have to. And so if this argument is not equal to 2, I can print an error and I can return I'm done. And I don't need to say else here because the only way I'm going to get here is if I did not execute this return, which means this if statement never fired. So that's just a personal style thing. Convenient that there's argc and argv. Is that from standard IO? Argc argv, yeah, is built into the compiler. That's part of the C specification actually, and it's tied in with the operating system. So you don't have to create error messages in ODP 408 because you expect that there's always going to be an argument. So 408, I'll be well behaved when your code gets tested. All right, and we'll look at 408 in a minute. So let's go ahead.
If we wanted to practice our programming skills, could we add it?
You can add it on your own, but it may not assess. If you put extra output, it won't assess. If you check for one argument, that should be fine.
Okay.
I don't think assess will get tripped up.
Okay.
All right. So what's going on here? How do we deal with this fact that you know when we do square ABC, we're getting weird stuff? ABC is not an integer, right? And what's happening is this scanf is failing to convert. All right. So how do we know that? Well, sscanf always returns a function value. And by a function value, I mean, you know, if we say something like integer result equals, result will be set equal to what I call the function return value, right? Now it's also giving us information, you know, in this argument and so on and so forth. But the return value of a function is, you know, at the end of the function when you say return blah, it's blah. And so I can capture that return value here in result. And this value will tell me whether or not it succeeded in converting an integer. Okay, so here's the deal. Result is the number of things converted. If the user did specify an integer, then result is 1. And that's all you know about the result. If it converted one thing, result will be 1. If it did not convert one thing, result will not be 1. That's different from saying result will be 0, result will be -1, result will be 2. It will be 1 or not 1. Okay? So if I want to know, did we succeed? Did we convert an integer? Check to see if results equal to 1. Alright, so if result is equal to 1, then it will print out number times number. Otherwise, I'm just going to print an error message and say this thing that you passed, argv bracket 1, is not an integer. Alright, so now if I compile this and I run it, if I don't put in an argument, it gives me that error message. If I put in a good argument, it prints out the square. If I put in something that's not an integer, it will just say XYZ is not an integer. All right, everybody's still on board. So if I input a bunch of characters followed by an int, it's going to say not an integer. Because what scanf does is it starts at the beginning of the string and it looks for an integer. That's what the %d says. But if I were to do this, 1, 2, 3, ABC, it's going to start at the 1, 2, 3. It's going to say, oh, that's an int, that's an int, that's an int. It's going to stop when it gets to the A, but it will treat the 1, 2, 3 as an integer, and it will say, yep, I managed to convert an integer, and it'll give me the square of 123. And that we don't have to worry about for ODP 408 either, because I'll always give you a good argument. Could I anticipate argv, argc to be basically universal, making it portable to Windows? So Windows and universal are kind of like antithetical, because Windows is proprietary. They don't want things to be universal unless it helps them. But I believe if you write a C program with argc, argv, and you were to run it from like a DOS prompt, I believe it would pick up those arguments correctly. And certainly in WSL and stuff, that should work the same, because that's basically Ubuntu. But universal on Linux systems, definitely. Universal on other systems, maybe. Kind of depends. But it should be. I mean, that would be a nice world. All right. Questions on this? So let's look at ODP 408. Oh, good. Someone says the video seems to have cleared up. All right, so ODP 408, you're writing a program, but instead of printing the square root of an argument, instead of printing the square of an argument, it prints the square root. And the argument should be a real number instead of an integer. And all that's going to change really is instead of using a %d to scan, you're going to use a %lf. And instead of using a %d to print, you're going to use a %lf. All right, so what does your program do? You say ODP 408 space, and you type a number, and it prints the square root. So I called my ODP S1, so if I type S1 and I type 4, it prints out 2, but it prints it with %lf, so it's 2.000. And if I say S1 5, it prints the square root of 5. And if I say S1, 22.78, it prints the square root of 22.78. All right, so that's what ODP 408 is. To write the code, you need to include math.h as well as standardIO.h. And when you compile, you need that -lm at the end of the whole GCC line. That links in the library that has square root. And then go ahead and assess it, and you should be good to go. Yeah, there's someone posted a Discord video on the fast square root algorithm, which I haven't looked at yet, but that would be interesting to see. There's a lot of creativity in the old games, because most of it was running on 8-bit machines, and trying to get speed out of something running at probably sub-megahertz clock rates is interesting. Numerical computations, you can take a whole class in that, and that's got some fascinating stuff in it. All right, so any other questions about this? So let's just do a floating point version of this. So I'm going to make number a double, and I'm going to scan with a %lf, and I'm going to print with a %lf. now if I say square the floating point number 1.3, it gives me 1.69. So I will push this code over to the Linux server in the shared code area, along with the code we wrote in the 10 o'clock class, which was doubling a number instead of squaring it, but it's basically the same stuff. But that should give you more information than you need for ODP 408. You don't need to check the arguments. You don't need to, check for if the argument's not an integer or a floating point number. You can assume that I'm playing nicely, right? So assume a single command line argument is given and it is a non-negative real. So you don't have to worry about error conditions. But for 409, we'll play with error handling too.
I got a quick question. It's been a little while since I've written C. Do we have to start it with .c, right? When you VI?
So yeah, your file name should be ODP 408.c, and then when you compile it, gcc-o ODP 408 ODP 408.c-lm, and that'll give you an ODP 408. And then when you assess with the name of the executable, ODP 408, and then the name of the source code, ODP 408.c. And yes, you can assume there's a command line argument. You don't have to check argc in this case. This is only because you know that you can trust your user, though. So I won't give you more or fewer than one argument. But if you want to check for it, that's fine. This is that book that I mentioned a little while ago, John Erickson, and seems like a pretty good book. It's accessible, but it gets into a lot of pretty deep concepts in the later chapters. And it's a pretty fun read. All right, any other questions? Screenshotted, excellent. All right, so tomorrow, so this was command line processing. What I want to look at tomorrow is dealing with arguments that you input while the program is running. So runtime arguments or program inputs. And that's going to get us into the fgets function. And other than that, sscanf is going to work the same. But that'll be the next area that we're talking about. All right, send me an attendance ping on the way out. Let me know you're still here. And yeah, 408 is a double, so a real number.
Thanks. Oh, Nick.
Yeah.
Real quick before you leave, can you type in the where I could find that README file? I was looking and I can't seem to find it for the how to fix the VirtualBox.
Oh, yeah. So go to. Let's get there the right way. Hold on a second. This was where my internet problems began yesterday. Was Canvas. It was like taking a really long time to do anything, and that seems to have gotten better. So let's see if I have this.
I was trying to get the CTC link yesterday and I couldn't get on.
I actually got a message from someone in IT saying CTC Link was down for a while.
Oh, okay. Well,
Yeah. Yeah. All right, so code from lectures, let's try that. And let's open that in a new window. So go up one level, parent directory, and then go into exrc.
Okay.
And there's a README. This is the file you want to download and save, and then the README tells you where to put it. And you basically just put it in .exrc in your home directory. And if you don't figure it out, just pop by office hours. It takes like a minute to do.
Okay. Oh, okay. So exrc, that's what you copy and paste.
Yeah.
In.
Yeah.
Okay. Yeah. No, I should be able to sort that out. Okay. Cool. Thank
Okay. Cool. All right. I will see you later.
you. Wait.
I have a question for you.
Yeah.
It's not related to this class though.
Okay.